Hello, it's Scott Manley here with the final part of Interstellar Quest. We have a warp drive capable spacecraft. We are using the super fancy unobtainium based technology we have discovered on Paul to enhance our drive systems and let us go faster still. This is the Enming Express. It seats a lot of people. We have like 6 crew cabins there that contain 4 people plus a couple of scientists and a pilot, so that is a full crew complement of 27 Kerbals. However, we only have 24 on board, the reason being that we have to pick up 4 of our crewmates out at Joule. They were of course exploring when they discovered the breakthrough material which enabled this thing to move faster than the prototype which we had previously tested to put her around our backyard in the system. No, Jebediah is at the controls because this really is a test flight. It is designed to go further than ever before. It is designed to explore strange new worlds, to seek out new life and new civilization, to boldly go where no Kerbal has gone before. But there is another secret side to this mission. The crew have not yet been told this, but this is a one-way trip. That strange Nan infection which was brought back on the Draco has now been called the nanovirus, and it is infecting hardware everywhere. Every single computer network, every single mechanical device is failing in strange ways. This is perhaps the last space mission they will be able to launch, because the nanovirus is propagating with such rapidity that everything is breaking down. It's becoming a chore to build even the most basic spacecraft. It's almost like bit rot is setting in on the fabric of reality. Like too many patches or modifications to a universe that is ill-equipped to handle this level of change. Now, the spacecraft has 3 different drive systems. First of all, we have the fusion drive system, which provides high thrust but a limited fuel supply. It does have the advantage of working inside atmospheres and providing enough thrust to counteract gravity. However, once this spacecraft leaves the atmosphere behind, it is able to hook into the quantum vacuum and push against this soup of ghost particles, gaining thrust from essentially nothing more than electrical power. Electrical power, which I will point out, comes from your standard antimatter-induced nuclear fusion power plant. In addition to that, we also collect antimatter, and we have a pair of antimatter generators which we can use should we collect enough of it. There we go, firing up the vacuum thruster, getting a whole 340 kilonewtons of thrust from this. That's enough to generate about 1.44 meters per second of acceleration, enough to get us into orbit and to maneuver anywhere we require. In particular, we are going to use this to maneuver ourselves into the antimatter collection zones, those natural magnetic bottles created by the magnetic fields of planets that store positrons, protons, antiprotons, all that stuff. Deploying the radiators, of course, because this thing is generating a fair amount of heat as well. Now, of course, this is a warp drive capable spacecraft, but I think it's only fair that during warp drive I fold everything away. Technically, the rings supplied by the Interstellar mod, they are a little small, I think, given what I understand about warp drive designs, of course, which are complete fiction. But nevertheless, yeah, I think the drive rings need to be bigger, so I've just tried to make my rule being that nothing actually should exist outside the rings, and well, that's led to a lot of compromises. This spacecraft is entirely self-contained. It isn't really designed to dock with anything. It doesn't have a separate lander. Those crew cabins, they do have the ability to navigate and land on a target in in times of emergency, let's say, but the spacecraft itself can actually land on those cubic octagonal struts, which are of course heavy duty landing gear. The problem I have with the regular landing gear is it has suspension, and suspension causes it to flex, and sometimes it will flex too far and the whole spacecraft will fall over and destroy itself. You can see we're flying by Duna on the way out here. We've got this warp drive running at 20 times the speed of light. Of course, that's 20 times the Kerbal speed of light, which is a little slower than the kind that we are used to, roughly 1/10. Yes, there's Duna, and now we're going to continue off towards Jool, because Jool is where the interplanetary team have been for the last few months, I guess. We're going to prepare to slow down. It looks like we're going to fly over the top of Jool. Once we get there, we're going to have to try to match velocities and put ourselves into a reasonable orbit. And of course, a reasonable orbit would be 9,000 kilometers, because that's where we're going to get the maximum amount of antimatter collection. So yeah, there we come in, flying over the poles, and as soon as I reach minimum distance, as in the closest point, you'll watch my vertical speedometer flip over. We're gonna drop out of warp over the poles, and then we're gonna warp in, moving closer to that 9,000 kilometer orbit where we really want to be. There we go, dropped out. Now it's a case of turning and pointing and trying to guesstimate where I actually want to be. Obviously moving too fast to actually get captured at this time, because we've picked up we've retained all the orbital velocity from being around Kerbin. But to be most effective, we don't want to kill off any of that velocity until we are as close to our target orbit as possible. You want to be, stripping off that velocity when you're close down, deep inside Jool's gravity well, so you're taking advantage of the Oberth effect. Actually, I'm not sure technically that applies here, since Oberth didn't really think about warp drives. We're obviously aiming for an equatorial orbit here as well. And we're going to drop down and drop out. Bingo! Right there. Now, this is going to be long, slow, and pretty tedious. We're moving about 6 kilometers per second relative to the surface. Of course, knowing that isn't that useful. Our orbital velocity is, however, 9,460, and we've got to probably have to drop our velocity down to about 4 kilometers per second or thereabouts at this altitude. Not sure. This is a long and tedious process, of course, given that we only accelerate at about 1.5 meters per second. And actually, over time, we fly outward. We continue to move beyond our sweet spot. Now, rather than make old-fashioned orbital corrections, it's better to just close up the ship, activate the warp drive to bring us back to an ideal location here. I'm looking to make sure that our time to periapse, I would like my time to periapse to actually be a real number, or it's negative, a non-negative number, meaning that we will actually be encountering periapse in the future. And there we go, 2 minutes to periapse. Fire up that engine again. Of course, if we were really in a hurry, we can bring up that fusion drive. The fusion drive is about 10 times faster, right? You'll also notice I made a minor error with my loadout, and I left a bunch of oxidizer, which I just got rid of between those two cuts. So yes, firing the engines, you can get a clue at how long I spent doing this, of course. Good thing is, I can play other games in the background while this is going on. There's a little something called Homeworld, which I might want to play. It gets released on Tuesday, if I remember correctly. But yes, here we are in our orbit. We are capturing antimatter, and now we need to perform the rendezvous. Sidney Kerman departs from the surface of Paul, very aggressively attempting to rendezvous with the interplanetary lab here. Collecting data even on the way up. Not that that's going to be particularly useful to him, but nevertheless, old habits die hard. The more science, the better. I think it's more that he's been trained to get science in exchange for snacks. So he feels that now he still needs to deliver on the science if he's to get his snacks. It's just, like a slave to the snacks, essentially. I mean, perhaps we shouldn't be thinking of these space capsules as space capsules, and instead they are high-tech, vacuum-sealed Skinner boxes, right? Okay, I'm pretty sure I'm stretching that a little, and there's a bunch of psychology students already writing comments as we speak, explaining the errors of my ways, basically. But yeah, if you don't know, a Skinner box or an operant conditioning chamber is a device which is used in studying animal learning behaviors, where you can condition animals and various species, let's say, to learn things and to operate things and to associate certain effects with certain behaviors with certain rewards, events slash punishments. It's complicated. Just go and read the Wikipedia page and you might get a better example, a better idea of what the heck I'm talking about. I don't actually know a great deal about psychology, but I have had conversations in pubs with people who really do know their stuff. Anyway, Sidzi is of course performing the final rendezvous and docking using entirely those dinky little RCS thrusters. They of course are very weak and very inefficient, but they don't kill everyone within 2.5 kilometers, which is considered a bad thing. Once he's docked and aboard, well, we deactivate that engine. We should have probably done that before he approached in case he accidentally put his foot on the accelerator. But yeah, now we're accelerating away using the main drive system, and we're going to bring ourselves down into a rendezvous orbit with the Enming Express. Of course, this is one of those very, very, very long burn situations again, largely down to the deceleration. I think if I do a sequel series of any sort, I'm going to completely avoid any of this high-tech drive systems and just stick to good old-fashioned chemical rockets, because time accelerating a whole lot is probably a lot more fun than running engines for hours and hours on end and trying to entertain myself with other stuff at the same time. Sure, those chemical rockets are inefficient and run out of fuel and leave you stranded in deep space, but at least they do that quickly. With chemical rockets, you're generally going to find out that you're doomed to get stuck on a solar-centric orbit with no oxygen and no hope of rescue in a few minutes rather than several hours. We depart, we say farewell to Paul, with the place that has yielded the real final secret to escaping Kerbin's system. Now, we'd like to adjust our inclination. The only problem is Tylo just wants to cause us all sorts of trouble. So I make only a minimal correction with the interplanetary lab and decide to let the quantum vacuum thruster on the Enming Express perform all of the rendezvous. And that does include several hundred meters per second of delta V in terms of inclination change maneuvers this close to Joule. I mean, obviously, from a pure efficiency standpoint, it would be much better to have the interplanetary lab perform the inclination change while it's way out and moving very, very slowly. But in both cases, these ships have huge amounts of delta V and they don't really care. The big problem, of course, is that I have to then sit and watch this happen. Speaking of sitting and watching, we have our space telescope far out on the edge of the Kerbin system. It is observing nearby candidates and has found an interesting object, a star which is much larger than the Kerbal star. It is putting out interesting levels of energy, but more interestingly, there are planet candidates. There is one particular blue object which is anomalously low density and appears perhaps to have the signature of life. Now, there may be other candidates closer to what the Kerbals expect to be a life-bearing planet, but unfortunately, the nanovirus has also spread out through the comms network to the Deep Space Telescope, rendering it useless. Really, they have no choice but to go with this strange anomaly of a world which defies all their physics, all their understanding of planetology and stellar physics. It doesn't make sense that an object so massive and so large could actually have such low density. Anyway, final course corrections are made. We bring the bring the spacecraft onto a close encounter with the interplanetary lab, bring the interplanetary lab onto a close encounter with the Eming Express. By slowing this down, you see what we're doing is we're bringing the intersect around, and eventually they're going to pass each other, and at that point, that's where we're going to aim to perform our final rendezvous. Of course, that will entirely be up to the Eming Express with its radiation-free quantum vacuum thruster system. Some people call this the EM drive. Now, you might have heard that, of course, this is one of these things that some people have designs for these things. None have been confirmed to work. And I am a skeptic, but one particular issue was addressed recently, and they actually managed to test one version of the drive prototypes or whatever in a vacuum, a proper vacuum. Previously they tested in a vacuum chamber, but it wasn't in a vacuum. But yes, vacuum or not, that's what we have to cross here. We have 3 Kerbals to fly across this 250 meters. Frame rate here was about 3 frames per second. We had 2 spacecraft that were very, very complicated. Large planets and, of course, Kerbals with their own lighting and things like that. Had to do this one at a time. I'm glad I didn't even bother trying to dock these. There's no docking ports on this, actually. I realized after I launched there was no way for me to even consider docking here. Also, it was amusing to realize that I couldn't actually figure out which crew capsule had room for my crew, and I began to fret that I had actually filled the whole spacecraft up. But no, we found it sitting here. Anyway, yeah, the EM drive test, it did still produce some sort of odd, unexplained thrust, but then again, the control object also produced thrust. So with everyone on board, it's time to say farewell to the Kerbal system, leave it before the nanovirus really starts wreaking havoc with their systems, power up the warp drive, stow the radiators, charge everything, and activate. Off at 20 times the speed of light, leaving Joule behind quickly. That virus may be moving quickly, but is it moving faster than the speed of light? I doubt it. There we go, 599,580,376 meters per second. And there is a last glimpse of Kerbal as it slides by, almost like a celestial tear on the face of an astronaut, leaving his home behind to go into the great black unknown. Tears of joy? Tears of happiness? Who knows? I imagine the enormity of this mission means something different to every Kerbal involved, all 27 of them. Days later, they arrive at the target system. Obviously, while they're in super deep space, they can ramp up the speed on these warp drives to even higher levels, but once they're navigating in a space full of potential debris and planets and things like that, they drop it down to only 20 times the speed of light. It would be dangerous to go faster, right? Because, of course, the difference between colliding at 20 times the speed of light and several thousand times the speed of light is clearly going to be fatal, right? Yes, there we go. This is, well, it looks like there's 8 planets here at least, some with several moons. This one has at least 4 moons here. In fact, this planet is larger than the Sun in the Kerbal's home system. But finally we reach our destination, a strange planet, anomalously low density, and only 1 moon. Unfortunately, the navigation computer is still set for the Kerbal's home system, so it keeps calling this Kerbal, even although it's clearly something else called perhaps, Kurth? We drop out of warp, and now we need to lose 30,000 meters per second of velocity if we're going to get in close enough to test that. And, well, that will be another long and tedious process. But for now, these Kerbals really have reached the end of their voyage. This strange place will no doubt yield its secrets to them and perhaps become a new home. The last messages they got from their home base was a message not to try returning. So whether they like it or not, this will have to be their home. At least until they can reinvent the rocket and perhaps explore this system further. This is Scott Manley, captain of the EXPS Experimental Starship Project, claiming this new planet as our new home base. Fly safe.